In this video, we're going to use Simio add-on processes to basically implement uh, the type-dependent processing time that we have on the oven station in this model. So if you guys remember from our previous labs, the way we did this model initially was that we used uh, a discrete empirical distribution to basically implement this idea of having different processing times for cold and hot customers um, in this server. So basically what we did, we used this expression for the processing time of the oven, which says basically for 30% of my customers, which are the cold customers, I want the processing time on the oven to be 0. Otherwise, for the remaining 70%, or with a cumulative distribution of 1, I want the processing time to be triangularly distributed with the given parameters in the problem statement. So this time in this video, we're going to use a different approach using add-on processes to implement the same logic. And the reason it is important to be able to use Simio add-on processes to handle such cases is that the only reason we could use this empirical distribution was that we had everything was probabilistic. In other words, we don't have any other conditions or set of conditions to basically determine our processing time. Since we only had the probabilities associated with each or with the distribution of our customers, we were able to use this discrete empirical function. Otherwise, if there were any other decisions involved, as I mentioned before, we wouldn't be able to, most likely we wouldn't be able to use this approach. So it is really important that we understand how we can implement this logic using add-on processes. So the first thing I'm going to do is to basically determine the type of the entities when they are created. So I'm going to click on the output buffer of my source and then go to the add-on process triggers, and you can see I have different options here, and you can click on your options and read the description or read their description. So for example, run initialized add-on process is triggered when the simulation run is initialized. Run ending occurs when the simulation run is ending. We also have entered and exited. So entered occurs when an entity's leading edge has entered this node. Exited occurs when an entity's trailing edge has exited this node. So what I'm really after here is to, at some point before the entity gets to the bread and meat station, I would like to determine the type of the entity, whether it's a cold customer or a hot customer. So what I would like to do in this model, it really doesn't matter if we define it on the entered or exited add-on process trigger. I'm just going to use the entered add-on process trigger. So I'm just going to double click on the entered. And as you can see, this add-on process is created, but it has no steps in it. So on the right hand side, you can see different properties of your add-on process. And on the left hand side, you can see different steps that you can add to your add-on process. And these are only the common steps, so you can click on all steps and you can see all the different steps that we have available to us. So what I really want to do here is basically probabilistically I want to make a decision whether my customer that is created is of type cold or hot. So the type of decision that I would like to make, it's not condition based, but it's probability based. And with a probability of 0.3, I know that my customers are of type cold. So what I would like to do here is to define the processing time of these customers, or to sample the processing times for cold customers and hot customers right after they're created. In order to do that, what I need is a model entity state. So I'm just going to click on my model entity, go to Definitions tab, and then States. And what I want is basically a real uh, state value or state variable that I'm going to call processing time on oven. And as you can see in the properties of this uh, state variable, it's a scalar, and the initial value is set to 0. Now, every entity that is created in my model will have this state variable associated with it. So initially, the value will be 0. What I would really like to do here, if I go back to my model in an add-on process, I would like to assign a new value to this model entity state. So for each entity, I would like to sample the processing time on the oven right here when the entity is created. So in my assign node on the true branch of my decide, I would like to have 0 processing time on the oven. So I'm going to select my state variable name. As you can see, you have a drop-down list with all the possible state variables that you can choose from. And what I'm really interested in is processing time, is basically model entity processing time on the oven. So I'm going to select my state variable, and the new value I would like to assign to it is basically 0. So essentially I'm not changing its value here because it also defaults to 0. But just to emphasize that we want this processing time for cold customers to be 0, I'm going to leave this assign step here. The other thing that we're going to do is to add basically another assign step to the false branch of the decide. So that's basically where we sample the processing time of the processing time on the oven for a hot customer. So in this case, we're going to go to model entity, processing time on the oven, and for this one, we will have basically our triangular distribution, which is, if I go back to our model, is basically random triangular with parameters half a minute, 1 minute, and 1.5 minutes. So I can basically use the expression builder here. So random, triangular, and my min, mode, and max will be half a minute, 1, and 1.5. So what happens now is whenever an entity is created, probabilistically we make a decision and we assign a value to its processing time on oven state variable. Now when I go to my oven, instead of this expression that we have here, if I click on my oven and my expression, what I would like to do is to change this to model entity dot, and as you can see here, we can see different state variables and properties of our model entity. So state variables are denoted with this symbol, and this little hand symbol is basically a representation of a property. So you can see all the different options, but what I'm really after is the state variable that we just defined, which is processing time on the oven. And I don't want the initial value, I want the current value, which I have assigned when the entity enters the output buffer of the source. So I'm going to say OK. So now when I run my model, what I would really like to see is that some of the entities will have 0 processing time on the oven, and some of them will have a random processing time that is sampled from my triangular distribution. So the way I'm going to verify that this new feature that I just added to my model is actually working correctly, I'm going to use basically the animation and running the model in the interactive mode. So what I'm going to do is to set a breakpoint on the input buffer of my oven server, and then I will run the model, and whenever an entity is about to enter the oven station, the model will automatically stop. So let me actually go ahead and increase the run speed to 50. So now this entity is about to enter the oven station, so my run stops at 1.54 minutes. So I've used the step mode to move to the next event. So now the entity, I'm still at the same time, 0 simulation time, because I'm using a connector here, is about to start the process. So now my entity will start its service at 1.54 minutes. And if I click the step, you will see that the entity in 0 simulation time, I'm still at 1.54, finished processing on the oven. So this shows that this entity had a processing time of 0 on the oven. Let me go ahead and run the model till the next entity gets to the oven station. So this new entity, my entity 28, enters the processing station of the oven at 2.92. So I'm just going to click on the step, see when it finishes its process. So now it's finished its process, and you can see that we're at a different time. So it's 3.95. So this shows that for this entity we had some processing time on the oven. And of course you need to run this model longer and verify that the logic actually works for more entities to gain more confidence that you have implemented everything correctly. The other thing that I've done here to verify that this alternative approach that I've just implemented for type-dependent processing times on the oven is actually correct, and my model is working correctly, is that I have run an experiment with the exact same configurations, in other words, with the exact same run length, number of applications, and warm-up period as the experiment that I did with the original model that implemented the empirical distribution as the processing time expression. And since I verified my original model before in a previous lab, so I'm confident that that model is right. Now I can use that model and compare my current simulation model with my original model to make sure or to basically verify my current model. What I'm going to do is to basically compare different responses that I have with the original model. And in fact, when you do that, you will see that the values are all very close to what I expected to see, which this time, instead of a queuing model, I'm using a verified simulation model to get my expected values. So the other thing I would like to do in this model is to change the symbol or the color of my hot and cold customers so I can distinguish between the two types of customers as I watch the model run. So in order to do that, what I need is basically multiple symbol state variables for my customers. And in fact, when you click on the customer object instance, you can add additional symbols to the list of symbols that we have. So the index 0 is the default, and we have also added a second symbol with an index of 1. So what I'd like to do is to change the index 0 symbol from the default green color to red. So I'm just going to select red and click on the model entity. So I've changed the first symbol to red, and I'm going to select my second symbol in the list, and I would like to choose a blue color for that. Now remember, when I run my model, I'm still using the default symbol that I changed to red. So all of the entities will be red in my model when I run the model. In order to tell Simio to change the symbol for my cold customers and hot customers, I need to go to my add-on process, and this time what I would like to do is to basically add another assign step to my true branch of the decide. So that's for cold customers. And what I would like to do is to change the value of this model entity proper state variable, which is my model entity.picture. I'm just going to copy this, and I would like to set it to model entity.picture plus 1. So basically I'm going from index 0, which is the default value, to 1. So now what happens is when I run my model, you will see that, let me reduce the speed factor a little bit, so 20. So now what you will see is that some of the entities are blue, some of them are red, and hopefully you will see more red because 70% of the customers are of type hot.